In this video, we'll talk about special products of polynomials, or as I like to call them, shortcuts for binomials. So, it should be mentioned here, and I'll keep mentioning this throughout the video. This is a direct extension of the multiplying polynomials video, and there are some just natural shortcuts that pop up when we're talking about multiplying two binomials. So if you prefer to not use the shortcuts and just keep doing the methods that we've talked about before, that being double distributive property or FOIL or the smiley guy method, you can still use those. This won't affect anything on those. So let's dive into the theory here. We'll talk about how to use these in a couple later examples. The first one we want to look at is the square of a sum, is what the textbook calls it. So the shortcut here is that we can say if I have something squared or something times itself, if we're talking about that something being a binomial, we can go ahead and say this is a squared plus 2ab plus b squared. Now that's the shortcut. You can jump from here to here if you want, and I will derive it for you here. If we were to FOIL this thing out, we'd have a plus b times the quantity of a plus b. So we have a times a, which is a squared, b times b, which is b squared, both positive. We're going to have a positive ab here and another positive ab here. Whoops. So what that would mean is that this would turn into a squared plus b squared plus ab plus ab, which simplifies to a squared plus 2ab plus b squared. Now again, this is a shortcut. You can do this just fine, or if we're doing an example, and we'll talk about those here in a minute, you can jump to using the FOIL or double distributive property, whatever you like. I'm not taking away any of those methods. We will not require you to do anything with these. These are just shortcuts that I'm making you aware of. Now, a lot of textbooks make a special case out of the negative. It works out the exact same, barring one small exception. I'm doing an a minus b squared, which again, that'd be a minus b times a minus b. That's what it means to square something, which using our shortcut, a squared minus 2ab plus b squared. Now you can do the FOIL to derive it. It works out the same way. If you see a minus here, just remember the negative term is the only one that changes. The other ones still stay positive. The last special case we'll talk about is the difference of two squares. Now some textbooks have different names for it, but that's the one that is generally used by most mathematicians. So this is the case if I'm looking at a plus b times the quantity of a minus b. Now this one works out a little bit differently. You have a squared minus b squared, and I will show you why that is. So if we FOIL this, we'll still get our a squared on our first term, our b squared for these terms, a positive ab or ba here, and then we're going to have a negative ba or ab. Now you may notice these two terms right here, they will cancel. So if I write this out, I'll have a squared, and remember it's a minus b squared because we have b times a negative b. So negative b squared plus ba minus ba, which those will cancel to 0, leaving me just a squared plus, or a squared minus b squared. Now again, this is a shortcut you can use. You can also do the FOIL if you like. We're not taking away any methods here. We're just giving you more options. Now real quick, let's actually put these into practice. So if I'm looking at this one, if I wanted to simplify x plus 3 squared, first off, I will do this with the more normal methods we've talked about, the double distributive property or the FOIL method. So the first thing I would do is I would write this as x plus 3 in parentheses times x plus 3. Okay, now I'm going to apply my FOIL or double distributive or smiley guy, whichever you like. I'm going to have x squared, positive 9, a 3x positive, and a positive 3x, which means I have x squared plus 9 plus 3x plus 3x, which simplifies to x squared plus 6x plus 9. Now the trick here is I can look at this term and I'm going to have an x squared. I can look at this term. I'm going to have 3 squared, so positive 9. And then I'm going to look at this term again and I'm going to double it. That's where I'm using the shortcut. This would be an example of the sum of 2 squares. So then I'll have plus 6, and then I'll tag on the x. Multiply it by that number as well, which in this case is an x. Now you may notice that's exactly what I have here. So whether you use the shortcut or the FOIL, it doesn't matter. You'll get to the same thing. It just may require you a few extra steps. Now similar line of thinking here with the x minus 5. I can do the same thing. And in this case, I will highlight the double distributive method just to show it off a little bit. So that way you don't have to take away from a particular method if you like it. I can rewrite this as x times x minus 5 minus 5 times x minus 5. Now I just have to be careful with this negative sign, but it'll still work out. So I'll distribute the x in here. I'm going to get x squared minus 5x. Then I'm going to have negative 5 times x, which is a negative 5x. And negative 5 times negative 5 makes a positive 25, which you may notice it'll simplify to x squared minus 10x plus 25. Now if I go back up to the top here, looking at the shortcut possibility, I'm going to do the same thing. I'm going to write x squared plus 25, because that's 5 squared. That's where those come from. I'll take those to the power of 2. Okay, and then I'm going to look at this second term, and I'm going to multiply it by 2. Now you may notice 2 times negative 5 makes a negative 10. And then I'm going to tack on the x, negative 10x. And it will be the exact same thing as what we got using the double distributive method. Now again, you do not have to use the shortcuts if you don't want to. We're just making sure you're aware of them. Okay, this last one, we're looking at the difference of 2 squares here. So I have x plus 7 times x minus 7. Now I can do my distributive property. And I'll have x squared, if I multiply the x's. 7 times negative 7 makes negative 49. 7 times x makes 7x, and that would be positive. X times a negative 7 makes a negative 7x. So if I write this out, I'm going to have x squared minus 49 plus 7x minus 7x. Now these 7x terms cancel. They'll go to 0, because positive 7x minus a 7x makes 0, leaving me just x squared minus 49. Now, if I'm looking at this, I can take the shortcut because I'm noticing it's an x plus 7 and an x minus 7, so all I have to do is square the x term, and then square the 7, which is make it negative. That's the shortcut. And you may notice it works out exactly the same. Now again, you don't have to use the method. It's just a shortcut that you can use if you want to.